Good morning, good afternoon, and good evening, depending on where in the world you're joining us from. I'm Brian Mink, co-founder and president of Data Science Connect, and we're happy to welcome you to GenAI Demo Day, brought to you by our headlining sponsors, Snowflake and Denodo, and made possible by our sponsors, Zenlytic, PromptQL, Fivetran, Google Cloud, and Precisely. Today, we're excited to welcome hundreds of attendees from all over the world for an exclusive virtual event showcasing the most innovative GenAI solutions through concise 10-minute demos. At DSC, we value your time and have designed this event to provide impactful demos without any unnecessary fluff. Quickly identify solutions that meet your business needs and connect directly with top leaders of pioneering GenAI companies. We're honored to hear from a distinguished group of experts today from some of the leading solutions in AI. Kaitlyn Wells, AI ML architect, applied field engineering at Snowflake. Chris Walters, engineer at Denodo. Paul Blankley, CTO and co-founder at Zenlytic. Rob Dominguez, engineering manager at PromptQL. Brad Moore, senior sales manager at enterprise at Fivetran. Holt Skinner, developer advocate at Google Cloud. And Nikhil Parekh, senior solutions engineer at Precisely. Before we begin, a few housekeeping items. To make this feel a little more in person, we suggest you add a photo to your profile and include your bio, LinkedIn profile, and other information you want your fellow attendees to see. Next, please take advantage of the Q&A and chat features throughout the webinar. Presenters may address your questions during their allotted 10-minute time slot or respond directly in the Q&A and chat sections on the sidebar. If you're wondering where your organization stands compared to others on your AI journey, check out the poll question in the right sidebar as well. Poll questions. And finally, if you'd like to learn more about any of the solutions you see today or book a follow-up call, check out the calls to action below throughout the webinar from our sponsors. Now, without further ado, Kaitlyn Wells from Snowflake. I'll pop your screen up here, Kaitlyn, and welcome. Turn things over to you.
Awesome, thank you. I'm Kaitlyn. I am an AI ML architect on Snowflake's applied field engineering team, specializing in consumer media entertainment customers based out of New York City. So today, I'm going to talk about AI at Snowflake. Specifically, we have over 6,000 customers that use AI every single week. And why do they use Snowflake? Mainly because we bring AI to your data so that you can focus on deploying solutions in days instead of months. So Snowflake's three key principles are that it's easy, connected, and trusted. So AI doesn't just start with agents. Typically starts with having a data foundation. 80% of unstructured data is actually unconnected right now. And so we're really investing in making that process easier with a comprehensive platform and infrastructure that's easy, connected, and trusted. Easy, we give you access to serverless scalable models, so you don't have to worry about managing GPUs or vendor lock-in. So for example, when GPT-5 came out, we were able to support it on day zero. Same with Claude. So we're constantly supporting that. We're also connected, so really focusing on, doesn't matter whether your application needs structured or unstructured data, but it's more the combination of that as well as with third-party vendor data on our marketplace is key to actually being able to get serve production level solutions. And then lastly, we do support interoperability with MCP and agent-to-agent coming soon. And then Snowflake's trusted. So it's an enterprise-grade platform with built-in guardrails, auditability, as well as role-based access control. Under the Snowflake Cortex umbrella, we allow you to ingest unstructured data through document processing, including multimodal, like audio and image data, to extract and enrich your maybe existing ML pipelines, or actually connect it with SaaS connectors like Confluence or your Jira data. We also provide lots of functionality to actually transform that data to be AI ready, whether that's AI SQL, using kind of like sentiment analysis, for example, or classification, or if you have data within PDFs or contracts, you can use our document processing functions. Once that data is either in a Snowflake structured table or in our vector database, you're able to connect it as tools within our agentic workflows. So today I'm actually going to show Snowflake Intelligence, which is our conversational assistant that you're able to actually hook up Cortex Search, Cortex Analyst, as well as custom tools and MCP servers in the future. And all of this that I'm going to show today can also be used programmatically via our agent API. So Snowflake Intelligence is one UI, but we expect our enterprise customers to also want that same experience for their users via like Slack bots or Teams, or even sitting side by side within their Tableau dashboards. So in today's demo, I'll focus on showing how a business analyst can use Snowflake Intelligence to help optimize their ad spend, as well as come up with recommendations or different ways to actually activate their ads and improve that. In today's demo, I don't have a UDF or external data, but you can wrap anything within Snowflake Intelligence within a user-defined function or stored procedure. So that can include use cases like scraping the internet, but doing so in a secure way where it's managed by external access controls and network policies. So today, this is the Snowflake Intelligence UI. So imagine I am a business user or business analyst within a marketing media agency, and I have access to several different agents that maybe my data science or my AI platform team has set up for me. So assuming I have access to this marketing genie agent that has my historical 2024 data. So I could just ask a quick question. What was the performance by platform in 2024? And so here, even with a typo, it's able to identify that I'm looking for the performance and infer that. It's also able to identify based on this question that it needs to access structured data. And so it's using Cortex Analyst to actually generate that SQL query, which we can see here, and then actually providing a summary output on top of that structured data. Can also easily, now that I know what the different performance metrics are, I can ask it to plot CPA by month by platform. So here we're quickly generating a chart, and it's able to actually identify that it already has that data from the previous tool, and now it just needs to actually generate that chart. Great, so now I'm able to pop this into a separate window. I could copy it, I could download this data. I could even say if I wanted a different plot, I could ask for that. Now I want to show the value of unstructured data. So how can I use AI to improve my marketing? So before this, I actually downloaded a HubSpot research report that included, it was a 65-page report on trends on how are marketers using AI. And so here we can see it's using Cortex Search to search across that unstructured data. And here I'm even getting the different citations for where it's pulling information from the report. And then here I'm able to get a breakdown of what the report is and some recommendations on how I can actually use AI. And you could see there's concrete stats pulled from this report. So personalization is a big one, content optimization, and these are some different ideas. And I can easily provide feedback to an admin or upvote or downvote this. I see a question in the chart. So what does it actually take to create this? So this is the business persona. But now I'm going to hop over to kind of this agent persona. So within the Snowsite UI under agents, I can easily create a new agent. For the purpose of this demo, I've already set one up called Marketing Genie. And in this agent, I haven't done much. I've just named it. I don't have any response instructions, but I have connected the two tools, Cortex Analyst as well as Cortex Search, which I have previously created. And then I haven't selected a specific LLM model. I've just selected auto, but you could absolutely select that and ensure that it's guarded by role-based access control. In this admin setup, let me just go back to that. I can actually ask different questions here. So one of the questions I previously asked was, can you summarize 2024 performance marketing spend and analyze any trends? I can actually look at my traces here to actually see what's happening under the hood, where I can now use this to inform, should I add orchestration instructions or improve my response instructions? And so here, this is where it's easier to actually debug, maybe if you're having latency issues, or improve kind of which tools are selected. But just to recap, this I've shown an example of connecting kind of a BI tool data. This doesn't have to be limited to BI. Another example is I actually added our Cortex search service with Snowflake documentation, as well as my historical query history. And I can use Snowflake Intelligence to actually optimize my queries, as well as generate code to test out new Snowflake features. So by no means does this specific to like a BI or a business user persona, but that process to set that up took under 10 minutes to set up that agent. So to recap, Snowflake brings AI to your data and makes it really easy to use, regardless of whether that's unstructured or structured. And then again, everything that I've shown here is available programmatically via our agents API as well. Thank you so much.
Excellent. Thanks, Kaitlyn. Enjoyed the demo. If you want to book a follow-up with Snowflake, like what you heard, please click the call to action right there below on your screen. So now I'm going to welcome to the stage our next speaker, who is Chris Walters from Denodo. Chris, I'll bring your screen up on the stage and turn things over to you. Welcome.
Hello, everyone. Welcome. My name is Chris Walters. I'm a principal sales engineer with Denodo Technologies. And today I'm going to be discussing how to build your GenAI applications on a solid data foundation powered by Denodo. I'm going to start off with a couple quotes. According to Gartner research, 70 to 85% of unsuccessful AI projects fail due to data challenges such as poor data quality, distributed data silos, a lack of relevance in the context of their data. Those are some challenges that organizations are having. Then this came across this quote in CIO magazine that says, trusted, secure, and real-time enterprise data is the electricity that powers AI. So now how does Denodo provide that solid data foundation that drives AI success? Okay, so we're all used to AI applications that are built on large language models. Those LLMs are populated on publicly available data on the internet. What that's missing, of course, is the context of your organizational data. Data in different cloud environments, on-prem data sources, external vendor APIs, SaaS applications, for example. So wouldn't it be great if we could have the same capability that we're used to with the Geminis and ChatGPT type applications, but using the context of our organizational data? So that's where Denodo comes in. Denodo provides a unified point of data access, unified point of security and governance, which enables you to, for example, combine data from a lakehouse in the cloud with some operational data in an on-prem data source, combined with a vendor API, being able to consume that data without replication, creating pipelines to move the data into one physical source. That's what Denodo enables. You just build a simple semantic layer which points to the data sets in these underlying sources. And now that provides a single point of access for all of your data. And so now we have a Denodo AI SDK, which provides that powerful capability to AI applications. So it's a set of REST web services which implement the RAG, retrieval augmented generation pattern for providing AI applications with data from your organization. So now I can, invoke some of the methods in the AI SDK with a particular prompt, and based on that prompt, we'll then determine what data sets within what sources and what attributes it requires to answer that question. Then it formulates a query, which is sent to Denodo. Denodo then, devises optimal execution plans to retrieve data from these multiple sources in real time, return that data to the LLM, and again, using the RAG pattern, then generates a response to return the AI application. So that's the power of the combination of the Denodo platform and the Denodo AI SDK. So a little bit more about Denodo. We are, in a phrase, a secure, unified real-time data delivery platform. It enables creating a logical data fabric, which sits between various sources of data, regardless of where they may exist, and then we make that data accessible to various applications through various consuming mechanisms, such as AI agents, AI applications, which is, kind of relevant for this discussion. An important concept to understand is within Denodo, we don't store any physical data. We just store metadata, such as technical metadata of how to connect to a source, whether it be a REST API or a database, or in addition to the technical metadata, also the semantic contextual business metadata, which is really important when it comes to talking about the accuracy that we expect from our AI applications. The more business context that we have around our data, that helps to improve the accuracy. So that's a very important concept to understand, and how Denodo enables that. So let's look at Denodo in action. And let's give a demo scenario. I'm a bank. I have data distributed in multiple on-prem and cloud systems, and I need to provide a central point of unified data access to support AI applications. So let me go into our Denodo Design Studio, and this is what I would use to essentially create my logical data fabric. It enables me to connect to multiple sources, SQL sources, NoSQL, REST APIs, SaaS applications, basically anything that you can get data from that provides an API, you can consume within Denodo. So if I look at example here, I have some data in a Postgres database. And so I'll specify my connectivity information of how to get data from that source. And then I'll point to my technical metadata of this is the data that's relevant for me within the source, bank account information, customer loan, payment information, all that is what is the metadata which we have, which essentially form the basic building blocks of our data foundation. So once I do that from all the different sources, again, whether they be REST APIs or SaaS apps or databases or lake houses, you can have those basic building blocks of your data foundation. Once I have that established, this enables me to create AI-ready data products, which may combine data from those multiple sources and make that accessible to external applications. So here's an example of a data product called Loan Analytics, and see it has the contextual definition of what this view is. So it provides a description at the entity level, as well as what does each attribute means. And so to reiterate, the context and the metadata around what each of the data sets represent, what each attribute means, is very important from the context of being able to provide accurate results in AI. And so you can enter those manually, or you can use the Denodo assistant, which can then generate that description. So it would essentially send the metadata for this view, the attributes and what have you, and it's going to send it to a large language model. And so based on what you specify there, it's going to generate a description and send back, which you can then modify as need be. But that adds the proper context, which is again very important for the accuracy of AI. So that's how I would build my basic data foundation to complement AI applications. So now once I have this in place, I want to speak to my data, and that's where the AI SDK comes into play. So I'm going to navigate into a sample chatbot application, which uses the Denodo AI SDK, which enables me to speak to my data. So I can ask something in natural language, like what is the outstanding account balance? And once I do that, it's going to generate the vector embedding for this question, and then searches against the vector database in Denodo, which contains the vector embeddings of all my metadata, all the metadata surrounding all of my different views, different attributes. And once it does that, it determines what view can answer this question and what attribute can I get that information in. And so it formulates a query, sent to Denodo for processing, and it gives an explanation of what it did. It also returns these related questions, such as like, what is the average account balance? So I'm going to select that and go through the same process, create the vector embedding of this question, search against the vector database for determining what views and what attributes enables me to answer that question, sends the query, and here's our result set. So if you notice, some of these responses, such as this is more like, what happened, when did it happen? Those are more simple questions. But you also see this other question that comes up in orange. So what are the factors influencing the variation in account balances? So that's a new capability of the AI SDK called Deep Query. And that's similar to, deep research, which OpenAI and a few other vendors have, which is much more complex analysis. So rather than the simple, what and where, what and when type of questions, these are more complex how and why questions that require much more detailed analysis. So I'm going to jump back here to slideware for a second. And this is the deep query flow. I ask a question that requires multi-step, multi-source analysis. A deep query agent then determines a multi-step plan. This may involve dozens of different queries to different sources. And it fires off these different queries, gets a response, and then using a reasoning model, ultimately creates a report with the details of that analysis. So that's something that can take several minutes to run, just like if you're using deep research. So we're not going to have time to do that in the context of a 10-minute demo. But luckily for you, I did it in advance. So if I jump here to this tab, and so this is a question I asked: how can this bank improve profitability by 50%? And so it goes through a detailed analysis, looking at the data that it had to analyze. And it gives a summary of key findings, complete with different graphs and charts to support the conclusions that it came up with, strategic recommendations, very deep, lots of details around exactly what it did, how it did it, all the different queries that were run to support your analysis. All right, so let me go ahead and land this plane in the remaining time that we have left. All right, so these are 4 points I want to leave you with about the unique value that Denodo provides for enterprise AI as the main takeaway. First of all, real-time access, which enables combining analytical data sources with operational sources with external APIs, which augment the foundational knowledge in LLMs. You don't have to create pipelines to replicate and move all the data into one source. Denodo enables you to consume that in real time. AI needs to move at the speed of business, and Denodo enables you to do that. Unified access to all an organization's data across disparate sources and on-prem cloud environments, and also in a secure manner. Access to organization data, leveraging your existing authentication and authorization policies. And lastly, to improve the accuracy of AI, the semantics around the semantic metadata that provides contextually relevant business information to improve AI accuracy. So those are the 4 main points, which is unique by Denodo that no other vendor can claim. So this is our unique value proposition. So you can look at the call to action to learn more and to get a longer demo. So thank you for your time.
Excellent. Thanks, Chris. Enjoyed the demo. If you liked what you saw, make sure to book a follow-up with Denodo with that call to action below. So thank you to Denodo. And now I'm going to bring our next speaker onto the stage. So now I'd like to welcome Paul Blankley from Zenlytic. Welcome, Paul.
Well, thanks for having me. I'm excited to chat today.
Awesome. I'll turn things over to you.
Great. Well, thank you everyone for joining. I'm Paul. I'm one of the founders and the CTO of Zenlytic. Zenlytic is an AI data analyst. And what sits under Zenlytic is our Clarity engine. We think you need 2 things to be successful as an AI data analyst. You need the depth of SQL where you can answer questions that matter. You can't just answer simple questions that already show up on dashboards. You're able to extend beyond existing concepts and answer questions that really matter. What would happen if I changed this? What would happen if I moved this in this way? The what if questions, the why questions, and the questions that really drive the important decisions in your business. But at the same time, you need the trust of a semantic layer. You need to be able to answer those deep questions that aren't restricted by just what exists in the semantic layer. But at the same time, for business users to be able to actually self-serve on the system, they need to be able to trust it. And you need to be able to give that depth while retaining the trust of the semantic layer under the hood. And that's what our Clarity engine does. And that's why I'm excited to share it with you today. So we're going to go through 2 examples and walk through what that looks like, how Zoe, our AI analyst, answers those questions, and why you can get the depth you need and trust that you need out of our Clarity engine. So I'll hop in here. So I can ask Zoe a question just using my voice. I can say, hey Zoe, can you show me year to date the gross revenue, the number of orders, and the profit margin percentage for all of my different product titles? And Zoe will take my audio, she'll turn that into text, and she'll start answering this question. So first what she'll do is she'll look across the different definitions that exist inside of my semantic model, if any. So what she's doing here is she's able to say, okay, I'm not going to recreate a new definition of gross revenue. I'm going to reference an existing one, if there is one. And if not, I can extend these definitions to make sure that you know what you're looking at. So Zoe will search across all your existing context to make sure that she knows the right way to calculate these things to answer your question. Once she has that context, that metadata, she'll go in and she'll structure a query that references those and shows you the answers that you're looking for. So she'll structure this query here. And then she'll go and run that query. And when she runs that query, you'll see that it doesn't just come back with a big SQL statement. It comes back and shows me exactly what I'm looking at in ways that I can understand as a business person. So I can come in here and see, hey, this total gross revenue, this is verified. It's used almost 70,000 times across my different environment. It's calculated with product sales plus shipping, and this is a verified metric. I can trust that this is how I should be thinking about these things. And likewise with number of orders or with gross profit. All of these are numbers that are verified. They have this green check mark here. You know, as a business person clicking on these, that these are metrics that I can trust. But to answer my question, Zoe's had to extend beyond these basic definitions that I already had. And she extended beyond to answer this question about profit margin percentage. So here I can see how she's calculated this. And I can see that this is not a verified field. This is something that she's taken those base definitions and extended it to make this new calculation. I can ask Zoe, hey, how did you do this? Generate a description for me. Explain how you did this. What's going on? And she'll go through, she'll look at the SQL that she wrote, and she'll say, okay, this is how I've done this. This is gross profit as a percentage of net sales, revenue after discounts, revenue less discounts, less COGS, divided by revenue less discounts. And this gives me a really clear explanation of exactly what I'm looking at and how Zoe's extended my existing context to be able to answer the question that I need. The other thing that this lets you do is this lets Zoe help you build the semantic model as you go. Instead of having to have everything predefined or put all of your information into some system or do this big build out before you can start getting value and answering questions, all you have to do is connect tables and start asking questions. As Zoe answers those, you'll see this promote to verified option. If I click this, this will push this into the data model, and Zoe will then know that this is the definition for profit margin percentage going forward, and this will get that green check mark. And that's available to just the admins and developers. So this is a good example of how Zoe answers those basic questions and how she distinguishes between verified context that's 100% trustworthy and new context that she's extended to answer your question. The other thing, though, is that Zoe needs depth. Zoe can't just answer basic questions that you can pull on a dashboard or select extensions of those. She has to be able to answer the questions that really matter. And she can do that in this way. So I can ask Zoe a big question, the same kind of question I would ask someone on my data team, and she can go and answer it for me. Hey Zoe, can you tell me what would happen if I took 80% of my ad spend and allocated it from my channel that's performing the worst in return on ad spend to my channel that's performing the best? How would that affect my overall cost of acquisition? So here I'm asking Zoe not just to go and pull some data for me that could be maybe a tile on a dashboard. I'm asking Zoe to go pull this data and genuinely help me make sense of it. And Zoe's going to first give me a plan explaining how she's going to go and tackle this problem. And then she'll move on to pulling the data and tackling that problem. So here she'll parameterize the query, and pull the data that she needs to get that answer. Once she's pulled that data, I can see exactly where she's getting it from and that these metrics are verified or not. So here I can say, okay, let's view this as a table. I've got my different return on ad spends, my cost of acquisition, and my marketing spend here. So I can see exactly what Zoe's pulled. And then Zoe has access to more advanced tools. Here she's able to take this governed result that I've gotten using all my verified definitions, so I'm very confident that this is right. And she's able to actually run that scenario analysis for me on the fly. So here I can say, okay, if I reallocated 80% of this ad spend from Facebook or from TikTok, my worst performing in terms of ROAS, to Facebook, my best, I can see what my new CAC is and how that's changing and what that means in terms of my changing CAC costs. I would see a reduction of CAC of $38 here. So what this does is this lets Zoe help you go beyond just questions you could answer with dashboards to really answer questions that have the depth you need to answer the questions that matter for your business. Business users don't come to an AI analyst to just pull the same information they saw on dashboards faster. They come to an AI analyst to answer the questions with depth, but they need to know that they can trust these answers. And this is what our Clarity Engine gives you. You can see exactly where Zoe's pulled this information, that all this information is verified, so I can trust what she's done. As Zoe gives me summaries of how she's done this analysis, I can easily look back at this and say, okay, yep, TikTok is in fact the lowest return on ad spend. Facebook is the highest. So like all of this is correct. This is following from the data that I know. And that's how Zenlytic works. Our Clarity Engine gives you the trust of a semantic layer, but the depth of SQL so you can answer the questions that really matter. And I'll be answering any questions in the comments if anyone has any there.
Excellent. Thanks, Paul. Excellent demo. And you do have, well, looks like you got a question there. I think somebody's requesting your email address, so I'll let you handle that offline. But excellent demo. And if you guys liked what you saw, please make sure you book a follow-up call with Zenlytic at the call to action below. Thanks, Paul.
Yeah.
And with that, I will turn things over to our next speaker, Rob Dominguez. And Rob joins us from PromptQL. Let me pop up your screen here, Rob. And I'll turn things over to you. Welcome, Rob.
Appreciate it. Hope everybody's doing well today. It's great to see so many organizations right now talking about a few key things when it comes to enterprise AI, in particular talking about reliability, trust, accuracy, because that's very validating to see that everybody in the ecosystem is really focusing on these things now. What I want to do today with everybody is focus on what we're calling the enterprise grade reliability problem. And for a second, I want you to imagine that you built your own AI on data system for your specific business's domain. And you can imagine for any implementations you've done up until this point that it's connected, it's running, and it's ready for questions. And probably throughout the testing phase, there were some relatively kind of lower order questions that were asked of the system, and things ended up working out very well. However, the question becomes, do you trust it to answer questions like, what's our current WIP inventory at 7 Oaks? Or pull up patient readmission rates for DRG 470 this quarter? Or finally, run SKU analysis for our private label beauty products? And the honest answer is maybe. If everything is set up perfectly, it might get it right. But what we found is really hard is answering questions like this, because accuracy depends so much on deep business and data context that is very rarely, if ever, captured up front. There's a lot of tribal knowledge that exists in organizations, and that doesn't necessarily translate over to a semantic layer by default. The real problem that we end up seeing as well is that even when AI doesn't know, it's still going to answer, and that's often going to be with full, enthusiastic, sometimes sycophant confidence that comes from these large language models. And for an end user, that's not only dangerous, because confidently wrong answers aren't just useless, they're also, in a larger organization, a barrier to adoption. Whenever we end up having inaccurate AI responses that come back with, again, this false confidence, what we end up seeing is that it erodes trust in these systems, it slows down decision making, and then it ends up forcing the teams that are building and implementing solutions to really end up chasing bad data itself. So the gap that we have to solve is not just making AI capable of accurate answers, but it's also ensuring that the signals that we get let us know when it's confident versus when it's guessing. The way that we started thinking about this is by kind of asking ourselves this question to begin with of what makes a human what we would call enterprise grade accurate, if we want to start to qualify humans in that way. For a second, if we could just consider like a data analyst or an engineer on your team. And when a business user comes to them and asks the question, two things are typically going to happen. If we have this new engineer or this new analyst that's joined the team, they're going to be learning on the job. You know, their day zero knowledge, while they may be incredibly intelligent, is not necessarily going to be the same as somebody who's been at the company for 10 years and has all that tribal knowledge. So every interaction that they have with somebody that's more senior or somebody that has more context is going to help them acquire more and more business and data context. And their answers are going to end up getting better over time. Additionally, if they're hopefully being honest about things, they're going to signal when they're uncertain, especially in the introductory stages of moving into the company and starting to learn all of that context and knowledge as well. If they're not confident, they're going to tell you and they're going to explain why they're unsure. And that's going to end up opening up conversations to clarify, verify, and then eventually get to the right answer itself. So what we're really focusing on is trying to bring both of these traits into an AI model that you can deploy internally. That way it behaves as close as possible to your best analyst or your best data engineer, because they'll be continuously learning inside of your context, signaling when it's unconfident, and then of course explaining reasoning behind its answers. And when all these different components are done right, it ends up becoming your AI analyst or your AI data engineer that's accurate, that's transparent, and is continually improving throughout the entire life cycle of the adoption and application itself. So we get a question a lot of the time whenever we're talking with people of, are we building models? And the answer is no. We're using foundational models that are out there, and just the kind of clarity and transparency on things, we work with any of the providers that exist. If you want to do things that are on-prem, if you want to do things that are, your own customization of existing models that are out there, we can work with those as well. What we do try to start to think about, though, is what we would call kind of your custom company QL or your Acme QL model that represents AI specialized for your business and your data. A lot of times when we're thinking about this, we can imagine, generic SQL being run over these giant schemas. But in reality, what we're trying to do is build what we would call a DSL, or a domain-specific language that's unique to your organization. And that DSL itself is going to power a few different pieces. First off, it's going to power the planning and the execution of different tasks or different questions that need to be answered by the system itself. It's also going to provide reasoning about its accuracy so that you can understand why it answered the way it did and essentially how it arrived there. And then finally, some transparency through a visible reasoning trace. And that can work in a couple of different ways. It could be a plain language query plan, so you can understand as a business user exactly how this data is being allocated and aggregated and used to solve whatever question or prompt you've given it. But then additionally, if you're somebody that's on the technical side, you can always expand things and see the actual Python runtime and SQL under the hood that's being run against your schema and your semantic layer. There's two really killer features that we would say exist within the product itself. First, we have this native confidence signaling. So again, the model telling you whether or not it's sure, so you can trust or you can verify the responses that come back. And then again, this concept of continuous learning, so it will continually improve on the job, just like a human would, hopefully. This means that you end up having enterprise-ready solutions for you that are not just powerful, but also reliable and tailored really to your specific domain and your specific world. A good way of visualizing this is what we refer to as our accuracy flywheel. So you can think about AI itself learning on the job. So once your company QL model is set up, we focus on creating this flywheel itself by doing self-reinforcing loops that make the system smarter and more reliable over time. So the first step at the top of the triangle that we have there is going to be that when the AI responds, we actually are going to be, giving it a multitude of things to do, whether it's tasks, an automation, some kind of analysis, or asking for some insight. It's going to provide a confidence signal about the response that it gives to you. And that signal is going to let the user then decide how to act. If it's wrong or incomplete, the user can do some simple steering right within the conversational interface itself. You could say, don't look at this table, look at that one instead, or this is the metric that we use as our official definition, or this is what this acronym actually stands for, even though you made some assumptions based on the surrounding context of everything else that we have within the schema. So you can think of it kind of like coaching an intern, being a very conversational, very iterative process. Day one, they're not going to know everything, but when they tell you they're unsure, you can correct them and explain why. And the model will continually internalize that feedback and learn from it. It's going to adapt to all these different data changes as well. And it's going to store that knowledge. And the result itself is going to be that the next time the same or similar question comes up, the AI is going to get it right because it's going to be confident and it's going to be accurate. So that's the flywheel in action, working continually. What this ends up leading to from an organizational perspective is when we're talking about the new challenges of AI, we see leaders at organizations sitting at a crossroad, and the decisions that they make today are going to end up determining whether these systems get widely adopted, or as everybody who's being pessimistic about AI in general is saying, going to become obsolete in just a few years. Most teams today we see are building some kind of semantic layer or knowledge graph, and that could definitely be something that they're, doing DIYs, homegrown within the organization. It could be purchased, it could be both. But the trap is that a year from now, the value of that investment we're seeing has often dropped. And you might think that that drop is because of the lower accuracy of the models themselves or the responses that are coming back. But in reality, the problem is trust. The AI is so confidently wrong, and that it ends up eroding user confidence faster than anything else. So what we're finding is that the key to long-term adoption isn't starting with 90% accuracy, it's signaling how accurate something is from day one. And a system that's only 50% accurate but builds continually and continues to compound when it's wrong is far more valuable than one that's at 90% accuracy but hides the uncertainty. At least with the former, you can use it productively without, fearing silent errors that are going to end up torpedoing things. If you layer on the continuous learning on top of that, the system ends up getting better with every single interaction, and you shift from something that becomes or is fragile and move to something that's more durable and can stand the test of time. So without these two capabilities, we end up seeing that confidence signaling and continuous improvement with any AI system is going to feel brittle, it's going to be risky, and eventually it's going to be abandoned. The last thing I'll leave you with before we jump, just because I realize that I'm running very short on time here, is kind of doing a before and after comparison. So if we think about today, if you're using anything like Gemini, any other large language models that are out there from different providers, it's a pretty straightforward architecture where you send a prompt to a large language model and you get an output that comes back. But in order to improve accuracy, your team's going to have to do a lot of manual work, like running evaluations to measure quality, selecting and swapping models, providing a lot of context engineering to make prompts work, orchestrating tools, and then shaping the data layer to be more consumable. You can imagine shrinking a 10,000 table schema in something that will actually fit into a context window for these large language models. With company QL, what you end up is with something that goes to the model itself and returns three things: output just like before, but you also get data artifacts that come back and a reliability signal as well. In this model, instead of working on all kinds of this wrangling and data orchestration, you get to focus on evals, reviewing metadata, and improving that accuracy flywheel over time. And with that, I know I'm up on my time. So Brian, I'm going to go ahead and stop there for you.
Sounds great. Thanks, Rob. Enjoyed the demo.
So yep.
Appreciate it. And if you guys liked what you saw, make sure that you book a follow-up demo with PromptQL using the call to action below. And now I'm going to welcome our next speaker to the stage, who is Brad Moore from Fivetran.
Let me start over. Fivetran is not an AI company. That's just really weird that we're here at a, oops, actually, let me back up. I'm getting way ahead of myself. So Fivetran is not a AI company. We are a data company. We move data. And a lot of AI models are hungry for data, no doubt. Whether that data comes from a Salesforce instance or a SQL Server on-prem database or an SAP system or Twitter ads or LinkedIn ads or something like that. It is a data mess out there. Most companies that have gone SaaS have a million different SaaS applications. Companies that are still on-prem have a lot of databases. And you need all that data to create the LLM, to create the model. And that's what Fivetran is here for. So first of all, Fivetran has been around for 12 years, 13 years now going on. We have around 6,800 clients now, close to 7,000. We are established. We've been up and running really since the beginning of the modern data stack. And if you look at the modern data stack, tools like Databricks and Snowflake and tools like Fivetran and tools like DBT and Coalesce and all these fine tools that are out there in the modern data stack, Fivetran is the dominant player in that. We have a lot of customers that are on Snowflake and Databricks and BigQuery. We know that each one of those has a lot of customers that use Fivetran. So we are well established. in that space, and we are the data provider. But one of the things that we like to talk about is that AI is not free. And most of the time, most companies start AI at the wrong level. They start at the tools. Snowflake has a fine AI engine. Matter of fact, we demoed that at Snowflake Summit a couple years ago. And we do that as one of our regular demos. Snowflake is a great partner of ours. Databricks has a fine AI engine, right? And they start there. And so you can establish that interest in AI and you start experimenting, you start playing around with the tools, but you're not going to get a business benefit until you start at the business level. You have to talk to your executives and find out what business problem we're trying to solve. And are we trying to get more market share? Are we trying to get more dominance? Are we trying to get more revenue? Are we trying to lower cost? Are we trying to improve employee retention? What are those use cases that are driving AI? And then you can go backwards into what tools are available and what data do you need to answer those questions. So this journey and these percentages are where the interest is right now. And we're very few companies are getting transformational outcomes from AI yet. It's coming, and there's some tools, really well represented tools here that can help with that. But we think it's all about the data. We think that Gartner is right when it says that 75% of organizations state that the AI-ready data remains one of their top challenges. And it's the way that they're spending money is getting AI-ready data. So one of the things that we think are some barriers to data in an AI model is clean data, compliant data, and fresh data. If you're working an AI model off of data that's a month old, you're going to get month-old results. So you need to make sure that the data is fresh, that it's clean, and that it's compliant. And Fivetran is a solution for data that's ready. Whether your AI is in production, whether it's in a prototype, whether it's in getting business value and impact, whether it's all about data management or data foundation, Fivetran is the base of all of that. Because every single system, every single SaaS application, every single file needs to be included in an AI model. So if you look at it this way, one platform for powering all your AI innovation, any source through Fivetran into many, many different destinations, and then you build AI on top of those destinations. Whether your data destination is a database or whether it's a data warehouse or whether it's a data lake, Fivetran has solutions for all of that so that you can prepare your AI model successfully. So I'm going to talk specifically about data lakes. This is a pretty innovative capability that Fivetran has. We moved this way pretty strongly, but we can now put any of our sources into S3 or in ADLS or in Google BigQuery, or excuse me, Google Cloud. And we put the data there in Iceberg, and that, or actually in Delta as well. You can mount that data offline in Snowflake, in Databricks, from all these different places. And a lot of companies are using an S3 bucket or a data lake for AI, for generative AI models. You want to be able to combine structured and unstructured data. You want to take your structured data in a data warehouse-like environment, but combine that with unstructured data. And a data lake is a great place to do that. So I'm going to move on. This is one of our customers that is published, OpenAI. And they actually use both Snowflake and Databricks. And they have a lot of different connectors, but they have a AI result, and they were getting tremendous improvements in their metrics. So we have lots of those. So let me show you a quick demo of how Fivetran works. So no, I have to log in back in again. Sorry about that. My login got stale. This is Fivetran, the dashboard, and I'm not going to do a tremendous deep demo here. I'm just going to show you the high level of what Fivetran is. But you can see on this screen all the different destinations that we support. You can see all the different.
Hey, Brad, sorry to interrupt, but we can't see yours. It looks like it's just a black screen to us.
Okay. Thank you. Let me stop sharing.
There we go.
Thank Thank you for that. So here's Fivetran. This is a dashboard that every customer gets when they log into Fivetran. Shows all their destinations and all their, we call them connectors, connections. And the connections can be associated with a destination. So in this case, I'm writing data from an email engine that we have to bring in email data to S3 in Iceberg. We also have here a Stripe connector going to Redshift. We have BigQuery in here. We have Databricks in here. We have Snowflake in here. These are all destinations that we can write to. And then you see all these connections types here. So we can write MySQL databases. We have GitHub. We have a Postgres database there. We have an RDS database. We have HubSpot. We have 5 Facebook pages. And I don't want to go through them all because there's like 800 of these source types. We also can bring in files. So let's talk about this in the context of an AI. So 2 years ago at Snowflake Summit, we did a lab. We had a second booth in our demo area. And we did a demo where we took a Postgres database of wineries in Southern California. It was just a raw database. We took Fivetran, we put that into Snowflake. We did some transformations out of Snowflake to create the LLM. We created a little Cortex application that you could query natural language and say, what winery do I want to go to in Southern California while I'm here at the Snowflake Summit? That booth was waiting room only. We had 6 stations around there and it was going full speed the whole time. So I think the point of that is that you need a full journey of AI. You can't just have an AI engine that's creating the LLMs and doing the Cortex things like Snowflake can do. You need the data. You need to go find the data, get the data, and bring it into your model. We also can do simple transformations. So we can take the data and we can clean it. So we land the data in whatever destination like Databricks, and then we can transform it. We have integrated transformations. And we have several different deployment options. Customers want to move data from on-prem and they don't want to move it through the cloud. We have a solution for that. They want to move files. They want to move event storage. They want to create a custom connector. We have more connection types than anybody else. And we're here to help. If you want more information about Fivetran and getting data into your AI model, then I invite you to connect with us. Thank you, Brian.
Excellent. Thanks, Brad. Enjoyed the demo. And if you guys liked what you saw, make sure to book a follow-up call with Fivetran at the call to action below. Now I'd like to welcome our next speaker to the stage, who is Holt Skinner from Google Cloud. Welcome, Holt.
Hello there. So, excellent. Doing all right. So, let me make sure I'm actually presenting everything correctly. Share screen. Okay, then. So, hi, everyone. I'm going to talk a little bit about the agent-to-agent or A-to-A protocol today. So we're seeing an explosion of AI agents out in the industry right now. Each of them might be good at very specific things, but A-to-A works to solve the problem of how they can all work together on complex situations. So a little bit about me. My name is Holt Skinner. I'm a developer advocate for Google Cloud AI. I live in Austin, Texas. I'm also a professional classical singer. I do a lot of concerts and stuff in the Austin area and around the country. So extra little tidbit there. So I actually have here an introductory video that you can watch if you don't want to listen to me right now. This is goes a little bit more in depth than what I'm able to do today, but goo.goal/A-to-A-video. It is currently unlisted, unfortunately, so you can't just find it by Googling it, but just a little thing to go to. Nope, I'm not going to do that. So imagine that you're trying to plan a trip and trying to build out a multi-agent system that could do all of this. So you might want to have a single agent that's kind of your travel agent, but that particular agent might want to interact with a bunch of other ones, right? You might want to have a different agent that can do flight booking, one that can do tour guides, one that can plan activities, and one that can book all of your hotels. Right? So you can do this. However, it's a whole lot of work to build all of these, and you might not have access to all of them immediately. So you may not have the source code for an agent made by Marriott or one made by Delta or insert other travel related company here. So the thing is, you don't have to build every one of these. You might be able to rely on someone else's agent, but it could be written in a completely different framework, running on a different host. It's complicated. So enter the agent-to-agent or A-to-A protocol. This is an open standard designed to be the common language for all of these different AI agents. A-to-A facilitates communication between a client agent, which is the one that's interacting with the user, and a remote agent, which can be on a server anywhere, essentially. The client agent is responsible for formulating and communicating all the requests, and the remote agent is responsible for acting on those requests to try and provide the correct information or take the correct action. And so these remote agents can also be in a mesh of sorts. They could be interacting with each other, right? So a lot of different partners around the world have agreed to support this agent-to-agent protocol. So the idea for this is that it's going to be a universal standard, and if you're going to make an agent that is going to be accessible by anybody except yourself, you should probably make it A-to-A compatible. So I'm going to talk a little bit about the capabilities of that and a little bit of how to implement all of this. So some of the key capabilities and features of this are discovery. So agents must advertise all their capabilities, their name, description, all that kind of stuff, so that different clients will know how, when, and how to use them for specific tasks. This is done with what's called an agent card, which is kind of like a digital business card for the agent. And then we have negotiation. Clients, agents, and remote agents need to be able to agree on communication methods like text, forms, images, binary data, all that kind of stuff in order to ensure proper user interaction. Task and state management. So client agents and remote agents need some kind of mechanism to communicate their current status on tasks that they're going to be working on, any changes that are happening, dependencies, and all that kind of stuff throughout task execution. And they need to be collaborative. All of these different things must support dynamic interaction, enabling agents to request clarifications, information from the user, all that kind of stuff, or complete sub-actions from the client, other agents, or users. So that sounds great. Is that all you need for an agent stack? So A2A is a great foundation for any kind of agentic system to build out. However, this is not the only kind of thing you can do. This is the recommended agent stack from Google Cloud. So we have everything runs via the agent-to-agent protocol. We recommend deploying your agents on Vertex AI Agent Engine. This is a managed platform that is used to deploy, manage, and scale all of your AI agents in production. However, you can use any framework that you want for that. Of course, Model Context Protocol, an open protocol that standardizes how applications provide context and do tool calling with LLMs, which I'll talk more about in a second. And then we also have Agent Development Kit, which is an open source code-first toolkit. It's a Python SDK and a Java SDK that lets you build, evaluate, and deploy AI agents very straightforward. We have a lot of different customers who are using it nowadays. So the number one question that I get about agent-to-agent protocol is A2A a competitor to MCP, right? So A2A actually loves MCP. A2A and MCP relate because they are complementary, not competing protocols. MCP is how an agent connects to its tools, APIs, and other resources. It's just a standardized way that an agent performs function calling, or how it can interact with its own capabilities or external services that it has access to. A2A facilitates dynamic communication between different independent agents that are acting as peers. So A2A is all about how agents collaborate, delegate tasks between them, and manage shared workflows. So you might actually see both in a sophisticated agentic system. The agents will use A2A to communicate with other agents, but they'll use MCP to interact with their own tools to get part of the job done. I'm actually going to show you a couple of spots here in the documentation that illustrate some of this here. If I can open it up. So if you go to this particular page here, this kind of illustrates some of the differences in how these might end up working. So if you have an agent, it's going to be communicating with other agents out there that might be kind of a black box of sorts. The MCP server essentially acts as part of this agent. It's simply going off to, it's going to the MCP server to complete a very specific task. You can kind of think of these as deterministic actions. MCP will usually be doing things like fetching data from a database, or making a change to a database, or fetching data from a website, or something along those lines. It's typically following more structured data. It's going to be like just a function. So you'll have input fields and output fields, all that kind of stuff. when you're using A to A and talking to agents, agents are likely going to respond with free-form text or things that are things like images and videos or whatever is being generated by the agent. So it's a little bit, it's a lot less deterministic, and it's probably going to be powered by an LLM somewhere. Okay, back to the slides here. Okay, so first thing I recommend everyone do on this is to go and get the code, look at this tutorial, and kind of follow through how all of this stuff can kind of be implemented here. So this is available in the agent-to-agent protocol documentation. It's a pretty detailed quick start guide that shows how to build one of these from the ground up. It shows kind of a hello world example that's literally just, okay, how do I set up the SDK and all of that stuff? How do they all work together? And then there's some more in-depth ones that show how to do this with a land graph example and some other things. So that also begs the question here: is this exclusive to the Google Agent Development Kit, or does it require a specific framework, anything like that? Absolutely not. It can work. Agent-to-agent protocols designed to work with any framework, any model, all of that kind of stuff. It's not exclusive to Google technology or anything like that. So I'm going to give you a few links here to kind of keep on exploring on your own. The A2A documentation is here at a2a-protocol.org. You can see that intro video that I talked about that goes into more of the details. You can see all the key concepts, how it relates to MCP, agent discovery, enterprise stuff, the kind of life of the tasks that go on with it, as well as the full specification, our community, our partners, SDK reference, all that kind of stuff is in there. Now, be very careful with this because, whoops, let me go back. Because there are actually a bunch of copycat sites out there right now. I have no idea why that is the case, but for some reason, whenever you search A2A docs, you don't find the official website. You find a bunch of other random websites. Now, I don't think that these are dangerous websites. They don't seem to be giving anyone viruses or anything like that, but they are a little bit out of date. So be sure to use the official documentation, a2a-protocol.org. And now the A2A SDK is one of the most straightforward ways of setting all this kind of stuff up. It's just pip install a2a-SDK. We have a few other libraries in different languages as well. This is just kind of showing an example of one of those agent cards that kind of describes what the agent does. And then there's other things you can create in there, like an agent executor, which is what actually like kind of maps the A2A protocol to what your agent business logic is doing. And now the easiest way, I think, for all to use this at this point is with Agent Development Kit. So this one can be done with pip install Google ADK and then use the extra A2A. And it's actually really straightforward. If you're familiar with the framework, all you have to do is kind of define your agent. You put in all your prompting and all that kind of stuff in there. And then to make it A2A compatible, it's just a one-line piece of code to actually deploy the A2A app. So this is how you would actually expose an agent as an A2A agent. And then to consumer remote agent, it's very similar as well. And this can work no matter what framework is being used. So you can actually do this if it's a land graph agent that's supporting A2A or BAI or CrewAI or whatever else out there. And so we have a few different, there's a few different pieces of documentation here you can keep looking at for that. Now, this is probably what most people are going to be looking for here. Here's all of the samples. We have a lot of different examples in this GitHub repository here that show how to implement the protocol using a variety of different frameworks. And also some that don't even have frameworks in there as well. So one of the things that I find most useful here is this A2A Quick Start notebook. I'm not going to run through all of it now because I don't have time for all of it, but it kind of shows how all of these different things can be set up. It actually shows kind of a little deeper into the specifics of how all the different parts of the A2A protocol are used. Like it shows an agent executor, it shows the agent card, all that kind of stuff being set up. So you can definitely do it this way, but I find it easiest to kind of use the ones that are built into the framework as well. And something else that is good to note here, under community, I have a list here of all the different integrations that I know of that have or all the different frameworks that have built in A2A integration. I have ADK on here. I have BAI, which is made by IBM, LangGraph, and Pydantic. The ultimate goal for all of this is that most people who are developing agents shouldn't have to know that A2A protocol is being used. It should just happen by default with a lot of these agents. And so the way that this is going to be done is if we can get this added into as many frameworks as possible that are being used. So BAI from IBM has been very helpful throughout all of this as well. They just recently migrated their BAI framework from ACP, which was their own protocol, to A2A. They've joined the protocol. They've joined the technical steering committee. So they're all on board with this here. And they've made it very easy to just turn any agent that's been created in their framework over to an A2A agent. And the same thing, LangGraph's page is actually down right now. That's interesting. Well, here we go. They have also made this pretty straightforward to turn any LangGraph agent over into an A2A agent. And same with Pydantic. They have a very similar system to ADK where you just call one method and make your agent A2A compliant. Okay, and of course we have all of the GitHub repos here. We have the organization for the A2A project, which is owned by the Linux Foundation. The actual protocol itself and the documentation is here. The Python SDK, JavaScript, TypeScript, Java, Go, .NET, those samples. And we also have an inspector as well to let you test your A2A agents to make sure that they are compatible with the protocol. Okay, that was all very quick there. So how much time do I have left? I want to see if we have any questions that I can answer.
I think we're out of time.
We're out of time?
Just the 10 minutes, but do feel free to answer any questions in the chat as folks have them. And for the audience, definitely make sure to book a follow-up call with Google Cloud if you like what you see.
Excellent.
All right, well, thanks, Holt. And now I'm going to bring on our last but certainly not least speaker of the day, and that is Nikhil Parekh from Precisely. Welcome, Nikhil.
Hi, everyone. Hope you're all doing well. I'm Nikhil Parekh, Senior Solutions Engineer at Precisely. And today I'm really excited to walk you through Precisely's MCP servers and also show you how Precisely's contextual data can actually be the missing piece of the puzzle to completing your AI journey. Before I begin, just to tell you a bit about Precisely. Precisely is leader in data integrity. We are serving more than 12,000 customers, including 95 of Fortune 100 companies, and brands like DoorDash, BMW, Walmart, and others relies on Precisely for the most important, most critical parts of the business. We also partners with data leaders like Microsoft, Google Cloud, AWS, Snowflake, Databricks, just to name a few. So now that you know what Precisely does, let me show you how we can actually help you. So chances are you already invested in AI. It could be through any platform. It could be OpenAI, it could be Google, it could be Anthropic, Claude, or any other platforms, right? And chances are it is already powering most powerful or most critical parts of your business, like risk assessment, resources allocation, location-based personalization, just to name a few. And the common issue with all of these models is they are only as good as the data that is used to train them. And a lot of the time, when you actually let all of these models run wild on the internet, what you will see is the response that you're getting back are from some of the most unreliable sources. And when you're getting answers from all these unreliable sources, at that point, it is just noise that is nicely packaged and shown as insights to you by all of these models. And headlines like this gives us a daily reminder that while AI can be really powerful for, let's say, writing emails, generating images, or just for your personal projects, when you actually introduce AI into enterprise settings, the stakes changes entirely. Now, in basically enterprise setting, the wrong answer isn't just inconvenience, it can be catastrophic. And to give you a reality check, chances are your data isn't ready. So while almost all organizations say that they're utilizing AI and training AI models, only 12% report that their data is actually ready for AI initiatives. So the rest 88% are training these really smart, intelligent models based on incomplete and really low quality data. That can have severe consequences, like hallucinations can start to creep in, model can underperform, and you can get really inaccurate predictions, which can cause a lot of losses in the business. And when you actually introduce location into this mix, the problems becomes 100 times worse. Because a lot of the time, location isn't just another piece of data. Locations can most of the times be the most important part of the data. Now, just think about it. Just to give you an example, let's say my house is on fire and I call 911 dispatcher. And let's say they, rather than using actual point level data, they uses the entire address to send a fire truck. Chances are the fire truck can be on the wrong end of the street while my house is burning. So a lot of the times, it is really important that you have point level data. And for all of these reasons, features like geocoding, property attributes, and routing becomes really important. So to tackle all of these challenges, Precisely has introduced MCP servers. So rather than relying on sources from internet and all these random unknown resources, you're actually getting data from Precisely directly. So you know the data that you're getting from all of these chatbots are actually reliable and trusted data. And also you can fit all of these MCP servers that I'm going to show you today in any model. It can be Claude, it can be Gemini, it can be ChatGPT. The demo that I'm going to show you with is with Claude, but everything that I show you can be like replicated in any other chatbot as well. So let me show you a quick demo of how precisely MCP servers really work. So let's start with something basic. Let's start with, let's say I want to autocomplete an address. First of all, I'll just turn off the Precisely MCP server to see what Claude will give us without using any MCP. So it says that I think you have provided me this address, but I'll need more context to help you autocomplete this address. Could you also provide me city, state, and zip? I mean, if I give all of the information, at that point, it wouldn't be autocomplete, right? So let's now try with Precisely MCP server and see what it gives us. So now, rather than relying on internet or the data that Claude is basically trained on, it is actually hitting Precisely autocomplete API to get this response. And you can see I got a full address with a C++4 and also coordinates. So you are basically getting a point level data. Now let's try something complex. Let's say I'm interested in this property, but I want to know that, what is like property features. Now, information like this can be really useful in when you're dealing with real estate, or you just want to know a bit more about this property. So it is hitting our property attributes API, which actually includes everything that you need to know about a property, like the cost or the basically the sale price, the number of bedrooms, the number of bathroom, and everything that you need to know. And then it is actually chaining with the other API. Let's say it is also getting into neighborhood and schools. So now I have this entire picture that I need to know about this property. So I have living space, number of bedrooms, number of bathrooms, financial information, what the neighborhood looks like, the schools, and basically everything for location. Now, another important aspect could be risk. Let's say I want to know about wildfire and crime risk. So now it will hit our wildfire API. So all the data that it is currently getting that you can see on your screen, it is directly coming from Precisely. And Precisely actually confirms all of the data from 15 different sources that we have. So first it got all the information for wildfire. Now it is getting into crime index API. So it got wildfire, that wildfire overall risk is minimal, and why it is, and what is the rating that Precisely is giving us, and it will also give us a nice summary. It will go into like crime index, that okay, it is above average for this location, and what should you consider. So let's say crime is high, and I want to know what is the PSAP information, public safety. So now it is going into PSAP API as well. And to get all of this data, Precisely actually calls all of this department to make sure the data is current, and actually it is correct as well. So everything that you say is coming from some random sources. So all of this information is something that you can trust and rely on. And I'm just barely scratching the surface here. If you look at the API, there are more than 44 APIs, starting from autocomplete to geocode, to US geocode, addressing information, everything that you will need for basically in terms of location, and also data quality check, like validating phone number, name, email address. You can get all of this information right into the AI that you're actually using. So yeah, that is all that I had. Thanks, Brian.
Excellent. Thanks, Nikhil. Great presentation. If you liked what you saw, please book a follow-up call with Precisely at the call to action below. And that concludes our Q3 demo day. Excellent presentations, lots of really cool solutions providers. So definitely make sure to watch the recording on our YouTube channel if you missed anything. It'll also be available at this same URL. If you just refresh the page in just a few minutes, it'll show up right here on this URL as well if you'd like to rewatch it now. So thank you again to all of you for joining us, and to all of our speakers. I want to say a special thank you as well to our headlining sponsors, Snowflake and Denodo, as well as our sponsors, Zenlytic, PromptQL, Fivetran, Google Cloud, and Precisely, for making this webinar possible. And we'll see all of you again next time. Thank you.